Okay, like I said earlier, we've talked about similar polygons, similar figures. We did like four-sided figures, five-sided figures, some triangles, right? But we're going to talk specifically today just about similar triangles. So let's write that down. So it's similar, and we're going to be real specific and just talk about triangles. All right, similar triangles. Now we know what we mean by, we've been talking about this for the last day or so, about what it means to be similar. So if I had a triangle right here, and then a triangle right here, in order to be similar, what must be true about the angles, the corresponding angles? They got to be equal to each other, right? So the corresponding angles, the angles that match up, have to equal each other. But what has to be true about the sides? Do the sides have to be equal as well? No, because if the sides were equal, then it would be congruent, right? So what must be true about the corresponding sides? They are what? What is it? No, the corresponding sides have to be... It's not fair. I mean, I heard you say it. I knew you knew the answer. You can't just give them away. You got to let people think on their... You have to let people think on their own. It has nothing to do with honors. We've been talking about it all day today and yesterday. Okay? So it's in proportion. So two things must be true. And we wrote this down yesterday. We put a 1 and a 2. And if you have your notes out, it's probably right in front of you. Does anybody actually have your notes out? And you have it right in front of you, right? So it wasn't much of a stretch, was it, to come up with this? Because if you had your notes, it should be right in front of you. That the angles are all equal. The corresponding angles are all equal, but the sides are not equal. They are in what? Proportion. Interior, sure. They're they're in proportion, okay? Look at your notes. And it's a scary thing because probably not in your notes, all right? So anyway, so the sides are in proportion. I don't even think we even mentioned interior, did we? I don't even think we even said that word yet. All right, so the sides are in proportion. All right. What we want to do here is we want to be able to tell if two triangles are actually similar to each other or not. Most of the time they did this. Watch, if I said this was ABC and DEF, they told you that these two triangles were similar. Like at the top they would have said triangle ABC is similar to triangle DEF. All right, so if they told you that, then you know they're similar. But what if they didn't tell you that? What if you don't know that they're similar? Can you just look at them and say, well, it sure looks like he copied and pasted, and then he took this one, hit the shift key, grabbed the corner, and made this bigger, okay? Can you make any of those assumptions about this? No, you can't, all right? So you have to be told some stuff. And here's a couple things that they are going to tell you. Watch this. This is the first one. We're going to have like 3 of them we're going to talk about today. Here's the first one. If I can just show that one angle is equal to another corresponding angle, and a second one are equal, if that's the only thing I knew, I didn't know anything about the sides, I didn't know anything about this angle and this angle. It's all I knew was that A and D were equal and B and E were equal. If that's all I know, that's enough to say that these two triangles are similar triangles. You hear what I just said? If the only thing I knew about these triangles is that these two angles were equal to these two angles of one triangle equal 2 angles of another triangle, if I knew that, then I can say that these triangles are similar to each other. So if they're similar to each other, what then do I know about the sides? I know the sides must be what? In proportion. Exactly. You follow me on this? So they didn't tell me right away that these two triangles were similar. The only thing they told me is A equals D and B equals Z. It's the only thing they told me. That's all I need to know in order to say that these triangles are similar. And look, 2 angles equal 2 angles. Look at what we call this. Remember doing this back when we did congruent triangles? What we call this, we don't just call this angle-angle postulate. We call this the angle-angle similarity postulate. So hopefully you're writing all this down. Postulate. All right? So we call it the angle-angle similarity postulate. Similarity because what's true about the two triangles? They're not congruent to each other. What are they? They're similar to each other. So if I knew that these two angles equal these two angles, that means the two triangles are similar. Everybody see that? All right. I'm not going to give you any reasons and stuff, just because of our time frame. But let's move on to the next one. Tell you what, I'll just use the same exact triangles, just so we have a level of consistency here. All right, I've got two triangles again. Again, I don't know anything about these triangles just yet. I know nothing about them. All right, so what if I told you this? Tell you what, we'll name it again. We'll go A, B, C, D, E, F. Keep the same letters and everything. What if I knew this? What if I knew that if I compared AB to DE, and that equaled AC to, what do you think, DF, and that also equaled BC to EF. So if all that stuff was true right there, okay, if I knew, if I had some numbers in here, right, and tell you what, let's just put some numbers in here and just make some up. Let's say that that's 5, let's say that's 6, let's say that's, I don't know, 8, just be a little different, okay? Whoops, let's not do that. Let's make this one, let's make it 4. I know it might not look to scale, but that's okay. Let's say that's 4, and that's 6, and that's 8. And what if this one was 2, and this one was 3, and this one was 4? Okay? If I knew that information, I don't know anything about the angles at all, do I? I don't know that angle A is equal to D. I don't know that B and E are equal. I don't know that C and F are equal. But this is the only thing that I know, is that these sides are marked the way they are. Let's find out if they have, basically, the same scale factor, right? So 4 over 2 is what? 2, right? So AB to DE, that's 2, right? So 4 over 2, that's 2 over 1. What about AC? 8 over what? 4. Is that the same thing as 4 over 2? Absolutely. 4 over 2 is 2. 8 over 4 is 2. Does that also equal this? 6 over 3. What's 6 over 3? That's also 2. They all equal each other, don't they? If they all equal each other, then they are in what? The sides are all in proportion. So I don't know anything about the angles. All I know is that the sides are in proportion. If I know that, guess what I can say about these two triangles? That they are similar to each other. And here's my reason. They call it the side, side, side. What do you think's the next word? Similarity. Right. Similarity. And let's see if they call this postulate as well. It's a theorem, actually. Not that that's a huge deal or not, but anyway, it's the side, side, side similarity theorem. Or you can just write side, side, side similarity. That's fine. You don't have to put the word theorem after it. That's the reason right there. So guess what? If I know that these two triangles are similar to each other, what must be true about angle A and angle D then? They got to be equal, right? I didn't know that at the beginning, all right? But I know that now since I know these two triangles are similar. So A and D are equal, and B and E are equal, and C and F are equal, all right? But that's all this. If all that stuff's true, then the triangles are similar. So I'll put triangle ABC would be similar to triangle DEF. Does that make sense? I didn't know anything about the angles at first, did I? All right. All I knew is that the sides were in proportion. If all the sides are in proportion, then I can say that the triangles are similar. If the triangles are similar, that also means that the corresponding angles have to be equal. So that means this is the only thing I knew, but then I could figure out that A and D, B and E, and C and F are all equal to each other. We good with that? All right, here's another one. We'll use the same triangles again. Sorry, it can't be any different, but it's just easier just to copy and paste what I already have. What if I had this? Again, being pretty bland with my letters and my triangles, but that's okay. It gives a level of consistency. What if I knew this? If I knew that AB to DE equals AC to DF. I don't know the third one though, okay? I just know that this one to this one and this one to this one are equal. And I also know that angle A equals angle D. So let's mark this. They don't do this in the book, but watch. AB to DE. They're not equal to each other, but watch. I'm going to give that one big old tick mark and one small tick mark. I'm going to give this one 2 big tick marks. I'm going to give this one 2 little tick marks right here, okay? And then I know angle A and D are equal, so I'm going to mark them equal to each other right there. So look what I have. I have a side and a side. They're not equal, are they? Okay, but they're just in proportion. What about the angle? They're equal. And then these two sides, the ratio is the same as these two. If I have that information, that's enough to say that my triangles are similar to each other. What do you think I call this? Side angle side similarity. Very good. All right, so we call it the side angle side similarity, and I believe that's a theorem as well. Yep. All right, but we can just call it side angle side similarity. So if these two things are equal, if these two things are true, all right, I've got one pair of sides, a ratio equal another pair, and the angle in between them, then I can call that side angle side similarity. Let me give you a little worksheet. I'll let you get started on it. We probably need to do a little bit more tomorrow with it, but at least get started on it. And you won't have to do it all tomorrow then. So do as much as you can.